Hey, happy Monday, you cool cats and kittens. It's time for a new week of bell ringers, starting with today. Did you hear that? Did you did you hear that? Oh, that's my little kitty. Hi, Frank. Hi. Da 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 do 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 da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's really fun. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class. It's interesting too. It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class. All right, yeah, it's Monday and we're having a new week of stuff. Last time we met, you took the test. Most of you did quite well on that. And remember, if you want to retake it, you may. That's not a big deal. And oh no, here's the cat again. Anyway, yeah, last test we were talking about DNA and genes and these things right here. What do we call one of those? Right, that's called a chromosome. Right? And we learned about that chromosomes can carry the genes on them, and then they are sorted during sexual reproduction. You have a full set of chromosomes, which is copied once, split twice, and you wind up with 4 half sets of chromosomes, or what we call haploid chromosomes. Right? And those haploid cells we know as gametes. And yeah, inside the gametes is one copy of each set of chromosomes, right? So humans have, of course, 23 chromosomes from dad in a sperm cell, 23 from mom in her egg cell. Egg is fertilized, we get a zygote that has the full 46. And when we look at chromosomes under a microscope, right, we get what we call a karyotype. And that's what we're going to spend today talking about. A karyotype is just basically a picture of the chromosomes. And the reason it's used is to see if there's any interesting genetic affects or defects or mutations. It's hard to see individual mutations with a karyotype, but what you can see is extra sets of chromosomes. Like for instance, here's a karyotype chromosome, and if you look at it, right, it's got chromosome 1, 2, 3, 4, 5, 6, and all the way down until you get to chromosome 21, and there's 3 of them. So this person has 47 chromosomes. That usually means there's going to be some issues in development for sure. Now, if you had extra copies of, let's say, chromosome number 1, you wouldn't even develop. There's so many genes there, it would throw everything into too much confusion. But chromosome number 21 is so small that not that many genes on it, that having an extra copy doesn't affect your ability to develop into a person, but it does affect your ability to develop as a person. And then here's another karyotype. You see, they've got 2 copies of 1, 2, 3, 4, all the way down. All the autosomal chromosomes they have, but this person is XXY, 2 X's and a Y. This is what we call Klinefelter syndrome, and usually this person can survive because the X chromosome doesn't have that many. I'm going the wrong way. X chromosome doesn't have that many genes. I'm sorry, the Y chromosome doesn't have that many genes on it, right? But you can imagine that this person, the biggest problem they have is conflicting signals when it comes to reproductive parts. Right? Klinefelter syndrome is what we call this. So we can use karyotypes, and that's what we're going to do, talk about today in class and then today in lab as well. We're going to do the karyotyping lab. All right, let's have a good day.